Thank you, everybody, for joining us again on this webinar. Well, my name is Edwin Robledo and Jorge Garcia. We're part of the community managers, and you'll see our participation quite often, either if you have submitted a case or if you're participating of the EAGLE Forum, which is extremely active. And I always recommend everybody to participate. So you'll see our presence there as well. Now today we're going to be talking about EAGLE and getting started with EAGLE. The intention behind this webinar is that if you just recently downloaded EAGLE, or maybe you may have some experience, but there's some aspects of how to get up and running with EAGLE you may not understand. So we're going to be covering kind of an overview of the control panel, what information it gives you. We're going to start a simple schematic, define some connections, create the board, maybe use some manual routing, some outer routing, and define some polygons. So it's going to be kind of an overview. With that said, I'm not going to go ahead and give any more details because I think it's kind of a lengthy one and we're trying our best to stay within our time. So I'm going to go ahead and move this over to Jorge. So give me 1 second. Let me stop my share.
I think I can just share. Yeah, I can just share.
Okay, very well, Jorge. Okay, if you have any questions throughout the presentation, I will be manning the chat. And I'll do my best to man the Q&A as well as we go. But we will leave some space at the end of the presentation for some Q&A. Go ahead, George.
All right, sharing screen now. Let me know if everyone can see it. Check. Can everyone see this? Let me know.
Looks good, Jorge. Looks really good.
Awesome. Excellent. So as you guys can see, this is 9.1.3. This is our current latest release. This is the EAGLE control panel. This is the hub where everything begins. So when you open it, you open to the home screen. And this is relatively new. So if you're an old-time EAGLE user, this may surprise you. Our older versions did not have a home screen like we do now. But as you can see, there's a lot of useful information here. So we have recent files, so projects that you recently opened will show up in that section. Any news items will appear as well. So as you can see, new features on the right side, the upcoming webinars, which I'm sure many of you use to register for this webinar. There's the bundle, so any promotions we have will also show up. And we have a learn section, so you can go through various tips and tricks, videos that we've made, all overview. So you can use this page kind of as a getting started section, and you can just get up to date with what's new in EAGLE. So as far as functionality goes, what's important, you'll find it over here on the left side. Okay, these are the trees that contain the different assets that EAGLE works with. So we have libraries, design blocks, design rules, user language programs, scripts, cam jobs, spice models, and projects. So libraries is pretty self-explanatory. That's where all of our components are in EAGLE. You'll have the managed libraries, which are the default set that ships with EAGLE. So those, just as a key point, key reminder, the default libraries that ship with EAGLE cannot be modified. Okay, they're a good known state for support staff such as myself, and they can help me be able to help you whenever you run into an issue. So to keep that known good state, those are not modifiable. What you can do is you can use them as a resource for your own libraries. So whenever you see a webinar at the end of the month that talks about creating parts, we'll talk about copying from EAGLE's built-in libraries into your own so that you can make changes and create your own libraries. Okay. You can also store local libraries in the libraries folder that is in documents. So what you're going to notice is that each of these trees, for the most part, has at least 2 folders. One being the default examples that ship with EAGLE. Those are internal. And again, they're made to not be modified by the user by default. They're a known good state for me and other support staff. So those by default you can't modify. What you can do is you can do a file save as, copy them into your user directories, and then work with them from there. So that's the other folder you'll see in each of these trees. The first one is the user directory. Second one is what ships with EAGLE. Okay, so, and you'll see that in each of these. 2 folders, 2 folders, 2 folders, 2 folders, 2 folders being the default. Okay. First one is your user folder. Second one is the examples. Okay, or in the case of libraries, you'll have the managed libraries that ship with EAGLE, And then there'll be the section for my managed libraries, which are my own, and I can modify and alter them at will. So then design blocks are basically schematic and board pieces, circuits that you can reuse. So just as a really straightforward example, if you work in audio, let's say you're a pedal manufacturer, there's certain parts that are going to be the same for every design. You're going to have the same switch, the same input circuitry, same output circuitry. The magic happens in the middle. So you can make the switch, the input section, the output section, you can make those a design block. And when you go to design your next pedal, you just bring it in. And the schematic definition and the layout definition can just come in. So that's going to save you time because you're reusing something that you've already designed before, and you don't have to reinvent the wheel with every new design you're going to do. So you have your own personal ones in the design block section here, and you have the ones that ship with EAGLE and examples. Okay. So design rules. Design rules basically define the constraints of the board. Is the board manufacturable? So when you're working with the design rules, you're basically setting it up to match whatever the board house can do. So that way, if it flags an error, it's the same error that the board house would flag, and you need to correct it so that the board is manufacturable. You can have the most beautiful design ever, and it's no good if nobody can make it, or if making it is super, super expensive. So you'll have the default design rules that ship with EAGLE, plus a few that we include from manufacturing companies that have been kind enough to make design rules in EAGLE format. User language programs are basically EAGLE scripting engine. It's basically a C-type language. If you're familiar with C or C++ or any of the C family, you'll feel right at home here. Again, you can have your own set and the examples that come with EAGLE. EAGLE ships with about 120 if memory serves, and you can do some pretty impressive stuff with UOPs. They're mostly used for importing and exporting, as well as custom functionality. So if there's something special that you want to do and you don't see a built-in command for EAGLE, most of the time you can use a UOP to achieve what you want. Scripts are related to user language programs. Basically, they're EAGLE commands in a file, one right after the other. And EAGLE, when you give it a script, it basically just goes line by line and executes those commands. These are the shakers and movers of EAGLE. UOPs on their own are basically read-only. They can't modify anything on their own. So when a UOP changes something, it does so by writing a script, a list of EAGLE commands that EAGLE then just processes in order. Key point here is the eagle.scr file. This is a configuration script. This is the place we recommend any default setups to go. So if you have a default grid that you like, or special layers or special commands, all of that can be defined here. Examples include some other scripts that we can use pretty frequently as well. CAM jobs, this is the functionality of EAGLE that generates the manufacturing data, the Gerbers, the Exelon drill files. Now in the newer versions of EAGLE, you can actually export DXF files through this. So again, user examples, the ones that ship with EAGLE are, basic examples for 4 layers and 2-layer boards. Spice models, these are part of the new Spice engine that came in relatively recently in the version 9 series. So this contains all of the models for our Spice engine based on NGSpice. You also get some example files under the projects area. So projects area is one of the most important trees in the control panel. So the first folder is your user folder project directory. This is in documents in a folder called EAGLE. We recommend that you store all of your projects there by default. Every installation of EAGLE expects that folder to be there. So when you update, you won't have to move anything around. So that is our recommendation. There are users who prefer another directory. That's perfectly okay. You just have to set it up. So if you're not sure, or if you don't have a strong opinion about it, just store all of your projects here in the projects tree. Examples contains the examples that ship with EAGLE. Of note are the LTSpice examples that come. We have a lot of examples that ship with Eagle and really give you a good overview of how the functionality works. Any questions so far on the control panel, Ed? Anything that we should address before we start making a schematic?
No, not yet. Not at all. Just want to let you know that using the documents Eagle directory is a really good idea because in the past 2 years, the cadence of updates is so frequent that they're uh, sometimes you lose the placement of where your board, your schematic, or library is located. So the developers generated this method. That way, every time you update, your files are easily found by Eagle.
Mm-hmm. Okay. Now there's a few other options in the control panel, such as setting up directories and things like that. Those are more involved, a little bit more advanced, so we're not going to address them in this overview video. But if you ever run into any issues with those, please feel free to come to our forums and you can request help there or shoot us an email. Okay, so with that said, let's go ahead and start a project. Just get into the beginning of it. So what we're going to do is we're going to go to the projects tree. We go into personal projects. Now I have a lot. I'll make a new one, new project. It's organized alphabetically, so you guys can see here. So I will call this Getting Started Demo. In general, we don't like spaces, so I'm actually putting underscores in each of those. Okay, so you can see there, Getting Started Demo. You right-click on the project and you select New Schematic. That's going to open up the schematic editor. Okay, any questions thus far? What's going on over here?
No, nothing so far, Jorge. We're good.
We're good? Okay. So what we will do is we'll go ahead and let me see, because something is keeping my bar at the bottom active. So I'm trying to see if I can get it to go away. There. That's fine. We'll go with this. Okay. So as you can see, very straightforward. You just have this toolbar, these two toolbars on the left side, and then the other one's along the top. So what we're going to do is we're going to click on the Add command. So the Add command is the mechanism we use to add parts into design. What we recommend is you start off with a frame, always, that kind of defines your work area. Eagle ships with a managed library that contains most of the standard paper sizes. So I'll just use a letter landscape. Come over here and place it. Now I have my highlighting set up a little bit, to be really very contrasting. So if you see the highlight color is different than what you have, don't let that alarm you. By default, you don't have the high contrast option on, but I do. So what we'll do now is we'll start searching for parts, and I'm going to take this moment to actually give a good example of how Eagle's search functionality works. Okay, so let's search for a common part, the LM555. Okay, what's going to happen, you'll see that you get sorry, no match. And this, especially if you're new to Eagle, can be a little disconcerting because the 555 timer is possibly one of the best known electronic components in the history of electronics. But what's going on is that Eagle search isn't like Google. Okay, it's not, if you're more or less there, it'll help you out and find exactly what you're looking for. Basically, it's an exact match search. So if you are off by a letter or a number relative to what's in Eagle's libraries, you won't find anything. And the way we deal with that is using wildcard characters. So Eagle supports two wildcard characters, the asterisk and the question mark. Question mark basically allows you to have a wildcard on a single character, whereas the asterisk allows you to have a wildcard on multiple characters. So let's say that I know LM555, but maybe the suffix could be different. And if we look at a data sheet, we will see that. So I hit enter now, and we see that we find the LM555 in two libraries. And if we see, we'll find out exactly why we couldn't find it before, because there's a D package variant and an N package variant. Basically, you have the surface mount version of the 555 and the through-hole version of the 555. Now, let's say, just as an example, we wanted to generalize this further, because we know that the 555 timer can also show up as NE, UA, and a few other prefixes based on the manufacturer. So what we can do is we can do the asterisk wildcard here. So basically it allows any arbitrary number of non-white space characters be where the asterisk is. Okay, do a search like that. And now we get more options still. Okay, and it covers the other ones that we mentioned. So what's the key takeaway here? If you want to have the best chance of finding the part that you're looking for, just use asterisk. Asterisk is the most flexible, the most generic wildcard. It will give you the most results. Some of them, you know, you don't need. Like, obviously, I'm not looking for this 1 to 4 decoder. It's not what I'm looking for. But in that generalness, it did find these. And this is something that we want to make more Google-like as time goes on, so that it's easier for users to find the parts they're looking for. So now, having found the part, I'll go ahead and bring it in. Okay, put it right there. And you'll notice that the add command stays active. A key thing in working with Eagle is realizing that commands stay active until you either explicitly stop them or you switch to another command. So I can just keep putting in 555 timers to my heart's content. Okay, I hit escape, it takes me back to the add dialog, and now I can search for another part. Okay, so as you can see, the workflow can be very quick if you just keep switching. You know, you hit escape, find the next part, place as many as you need, escape, find the next part, so on and so forth. For now, I do want to get rid of these extra ones first to avoid confusion. So what I'll do is I will select them, press the delete key, they're gone. Select this one, press delete, gone. Okay, you can pan. If you have a three-button mouse, you pan by holding down the scroll wheel. Okay, and you can zoom by going backwards and forwards. Okay, pretty straightforward. So now what we'll do is we'll go ahead and bring in some other components that we need for the design. So one library that's good to always remember is the RCL library that ships with Eagle. This one contains passives, you know, resistors, capacitors, inductors, and pretty much all the packages you could ever need. So very highly used library in Eagle, if not the most used library in Eagle. So I'll go to RUS. It starts off with the through-hole parts, and then we can go into surface mount parts. So I'm just going to use surface mount resistors today. Okay, RUS, R0805. I'll bring in as many as I need.
It's an obvious comment that the ones that have the little 3D model ticker on it, you'll notice those are, yes, it just means that there is a 3D model associated to that component.
Mm-hmm. Correct. Okay, so I got those. Okay, now I'm going to put in some capacitors. Again, I'll put in 0805s. And like it was mentioned, you can see the little 3D.
Yeah, and there's a team of there's a team actually working on this and adding more and more components with 3D models as well.
Okay, I think that's all the caps. If I'm missing any, I have to put it in. Those of you who have worked with a 5.5 timer before, you may be starting to get an inkling of what I'm doing. Now we're going to bring in an LED. Eagle again ships with a pretty big LED library. For our purposes, I'll just use a generic 5mm LED, which we do have a built-in 3D model for. So, okay. I'll go ahead and place it there. And so far, I think we have most of the components we need. So let's talk about making connections. Connections in Eagle are made using the net command, okay, which is this one right here. Click on net, and you'll notice that when you get close to a pin, there's a little circle that pops up. Okay, so it's basically helping you to make the connections. So left click when you're within the little circle, and left click again. Okay. One thing to note, the 0.1 inch grid in the schematic, extremely important. On the schematic editor, do not deviate from a 0.1 inch grid. If you like the metric system, just change the units to be metric. It'll be 2.54 millimeters, but do not deviate from that size of grid, because what can happen is every symbol in any Eagle library you will ever run into is made to a 0.1 inch grid. That is our 25-year-old convention. If you deviate from that, you can find it difficult to get parts to connect. When you stick to a 0.1 inch grid, everything connects no problem. Okay? So very, very important. So I'll go over here, connect these. Okay. Alrighty. Now, one thing to note, the change in direction is automatic. So if you ever find that it's going kind of the wrong way, what you can do is you can just pull in the opposite direction, it'll automatically correct. Okay, we're good so far. I'll bring this over here. Okay, there we are. And we'll bring in this one over here. And now, so far, what we are missing are the rails, right? We don't have any voltage source in here. We don't have a battery or plus 5 volts or anything like that. So let's go ahead and add those in. We do that using the supply libraries. Eagle ships with 2. Supply 1 and supply 2. And these contain the supply symbols. So supply symbols in Eagle are special. Basically, every instance of a supply symbol automatically connects to every other instance of the same name. So for example, if you have 20 G&D supply symbols, they all automatically connect, even if you don't draw nets between them. So that really aids in the readability of a schematic. So we always encourage users to make ample use of supply symbols. It makes it really easy to follow the logic of a schematic. For this design, I'll just use a plus 5 volt supply symbol. Okay. Put that there. Okay, and I think that's good for now. And I'll grab a ground. By the way, to rotate, I'm right-clicking. And I'll put this one over here. And there we are. Okay, so again, we use a net command to connect them.
Please realize we're using the net command to define connections. Stay away from, we prefer if you stay away from wire or line command for your connections. Always use the net command.
Correct. Line now makes it clear that it's just an artistic tool. But before, sometimes users would use that one and it doesn't work the same. It doesn't connect things properly. So your connections always made with net. Now you'll notice I get this little warning. Merge net segment N$7 into supply net plus 5e. What does it mean? Every time you draw a net in Eagle, because all connections are defined by net name, Eagle assigns a default net name to every single one of these nets. Now I'm trying to connect a supply symbol. So it's seeing a conflict. The supply symbol carries a net name of plus 5e, and then the existing net has N$7. Do I want them to merge? Do I want it to now be plus 5e? I do. So I say yes. Okay. Same thing is going to happen here. Merge, yes. So whenever you see that, basically just say yes. 99.9% of the time, the answer is yes. So now what we're going to do is we're going to go ahead and one thing we're missing is an actual connector. In the real life, the board would need some sort of connector to the battery. So let me go ahead and bring that in. Now, we have many connector libraries. They're all prefixed with the word con. So it's con PC, con Phoenix, con Samtec. If you know the manufacturer, usually you'll find a con something library for that manufacturer. Okay? For the purposes of this design, and if you want to be really generic, you can use the pin header library called Pinhead. And you'll find that over here. Okay, and I'll just use a really simple 2-pin header. Say OK. There we are. And now, since this is just a connection for power, I can use the copy command and copy the symbols I already have. That way I don't have to go through the add command again. One thing, if I did want to go through the add command again, if you right click on the icon, you see how it has a little arrow here, little arrowhead pointing down. Basically, it has a history. Okay, so you can go through the last, I believe, 10 or 9 parts that you've placed, and that way you can access them quickly. And that applies to any icon that has that little arrow. So if you right click, you have a history or you have a default set. Happens with layers. You can define layer aliases. So keep that in mind. Whenever you see a little down arrow, it has a history. It has a right click that you can use for some extra options. Okay, so these are the basics. The only thing we're missing now is just to give these values. And we do those obviously using the value command, which is right here. Value, this will be 180 ohm. This will be 100K. This will be 470K. This will be 1 micro. You can put in the F or not, doesn't matter. 0.01, no, 0.1 micro. And then this one is 0.001 micro.
So while you do that, Jorge, he's adding values, but we have a question in regards of showing the supply library. Basically, what he does is that he uses the add command again, just like if it was any other part. But you go ahead and select the supply library. Now there's 2 supply libraries, 1 and 2. The one that he used in this case, if I'm not mistaken, was supply 1. Now the main characteristic is these are just rails. These are representations of supplies that are being contributed to your board but do not have a package associated to it. In other words, they don't have no footprint on the board. These are representing supplies that are actually coming in, and those were found in the supply library, just to let you know.
Yep.
Somebody's asking you if you could just show that library one more time, Jorge, if you don't mind.
Of course. We'll go over here. Just little trick. If you click anywhere in the library, if you type the first letter on the keyboard, it automatically jump to that section. So like S, find the supplies, supply 1, supply 2. Okay.
Another thing that to notate is that, as you could see, the libraries, I mean, you could change it, but the libraries are in alphabetical order.
So that brings me to one other key point, which is something a lot of new users try to do. Don't try to rename these. It won't change the net that they connect to. That's the reason that the supply libraries exist and they have so many different voltages in them, because renaming these does nothing. So the name of the net that they connect to is based on the device name, which is what you see here in the add dialog. Okay, so if the name of the supply symbol is 4.1V, that's the net that it's going to connect to. Doesn't matter if you rename it on the schematic. And that tends to trip up new users sometimes.
Yeah, don't associate the name of the component to the functionality of the voltage that has been associated to the actual pin within the library editor directly.
Correct. So it uses the device name in the library, not the instance name or the reference designator in the schematic. Okay, so we are good here. I'm going to go ahead and save. Give it a name. Getting started. Okay, and now we're going to switch to the board. Everybody ready? Can we switch to the board?
Okay, let's live on the edge. Just do it.
Do it. So you'll get this. It says basically board doesn't exist, which makes sense because we haven't created one yet. Do you want to create from schematic? We say yes. And there we are. Okay, so when you have a size limited version of Eagle, the free or the standard, you'll get this outline. And this outline will define the limits of your license. I have a Pro, I have the Premium. So I still get the outline because you should have some default outline. But in my case, I can make it whatever I want. Okay. So we have this. We can do is we can form a group containing all the parts. Okay. And the group command is always active if nothing else is. And then you can left click and drag to bring the group into the work area. If you right click, it'll rotate. Okay. And if you do a middle click, it'll mirror to the other side. But for now, I'll leave it like this. I'll put it right there. And there we go. Okay. Now what we can do is we can actually drag down the sides of the board, just kind of by clicking in the center and dragging, and just have it kind of fit, more or less. I'm not trying to be too perfect. Obviously, in a real design, you would probably have size constraints and other things requiring you to make the board fit a certain.
I would like just to notate here also, Jorge, that if you had the Eagle Fusion bundle, you could actually import that board outline from Fusion directly into Eagle.
Correct.
Just a little plug.
Of course, we got a plug. So now what you can do is you can just kind of drag and move things around and put them where you want them, however you see fit. I'll just do some basic motions. Now, one thing that's cool is you can take advantage of the align command. So for example, you can click this one and add this one. These two form a little group. And I could use the align functionality and say I want them to align to the top edge. And now they're both perfectly aligned on the top edge. I can do something similar with this one over here. I can go over here, select this one, select align, bottom edge. There we are. Okay, and then I can move this around a little bit as well. That over here. Now, when Eagle's not sure, you get this ambiguity cursor. And basically, you can right-click through the nearby items until it lands on the one you want. Once it lands on the one you want, you just left-click to drag it and put it wherever you want.
And when you do land on the one you want, you notice that one highlights. In this case, since he's using high resolution, you're seeing the change in the color. By default, you're just going to notice the same color, just highlights.
Mm-hmm. Yeah, it'll get a little bit brighter. Okay, so what I'm actually going to do is I'm going to move this one down to here. There we go. Okay, and this is good to start. If you do a rat's nest, the air wires will recalculate. I don't know how much they'll recalculate here because I really didn't move it that much. But rat's nest is the way to kind of straighten these out to make them shortest distance. So I click here, just keep an eye out. Does anything happen? Yes, it did clean up a little bit over here. It got rid of one. So I'll do Control Z. Everybody look over in this area. Okay, everyone look over here. Rat's nest. Okay, and it kind of cleans it up. So at this point, let's talk about some of the important routing features and copper features that we need. Okay, so what we'll do is we'll use the polygon command, which is, where's polygon? Over here. Okay, and we can draw the outline. Okay, so I could draw the pour as I see fit. Okay, it'll ask for a name. I'll call it ground. All right.
Polygons need to finish at the same point where it started. As soon as you do that, that's when you get that name prompt.
Correct. You also see that it becomes a dotted line. Okay. The other important thing to note, besides starting and ending on the same point, they can't run over on each other. So you can't have the outline kind of run on itself, because then it won't be able to calculate the fill. So must be a perfectly closed contour, starts and ends on the same point. So if I rat's nest it, you'll see that it fills in, and anything that is ground gets consumed by the polygon. So you see you get these little thermal connections, and that's the default. That's to help with soldering reliability. So everything that's ground automatically gets nicely connected like that. Okay, and we can use the rip command to turn off the polygon you'll see here, rip up all polygons. And we'll get back to this view. This view is preferred when routing, because that way you don't have all that color cluttering your routing area. Now, how do we route? Routing is done using the route command over here. And you'll see there's lots of options. Okay. By the ignore obstacles mode is basically full manual. You can do whatever you want. You get no help from Eagle to route. The default mode, though, is walk around. So here, basically, as you're routing, Eagle will avoid colliding with objects that are in the way. So for example, if I start routing this one, okay, you'll see that if I try to run straight through this resistor, it actually walks around it. So it makes it really easy to route complicated traces. Again, I can go in whatever direction I want. There we go, and it'll beep if you make a good connection, okay? So really straightforward. Now, let's say this one over here. Say I now need to put a transition. I need to put in a via. If I press the space bar, you'll see the via appears on the end. I can move it. Okay, and it will actually, in walk around mode, it will avoid running into anything that it's not supposed to. Okay. However, there is another mode, and that is the push. Look what happens with push. You see how it kind of moves the existing trace around to make room for the via? And it can do this with as many traces are in the way. So this avoids you having to move things to create space and come and route. It saves a lot of time. So say I'm happy with that. I go over here. Once you left click after placing the via, the layers transition. Now we're on the bottom. Now obviously I want to transition back to the top. And I can kind of pick a spot wherever I want to route. It's always going to respect the design rules. So it's not doing these moves and these changes willy-nilly. It's actually making sure that your manufacturing constraints are always observed. So it's protecting the design and making sure that it stays manufacturable. Okay, so the last of the routing tools that we want to show are these right here. These are the quick route tools. And again, we can spend a long time talking about these. But basically, these are highly assisted routing mechanisms. They'll actually do like the whole trace for you on whatever layer you're on. So as an example, I'll pick this one to signal, quick route to signal, and I'll pick for it to quick route to +5. So I'll click here, and you'll see it automatically routed all of that for me.
We will be doing we'll host that webinar again because there's been many requests for it, but we did do a manual routing webinar not too long ago. It had a really good comments, so we're going to go host that one most probably early October.
Mm-hmm. Yeah, and you can see it's really quick. Does a good job. You can do multiples. You can do just a single segment. You don't have to do the whole net. So for example here, maybe I just want to do this little air wire here. Go straight. You know, it does a good job of following the most obvious path. Now it does try to stay on the same layer. So it may have some issue doing these because we have a wall here of trace. So let's try it, but let's see what happens. Yeah, you see? It's got a wall running straight through there. So in those situations, you know, you would use, you know, the other routing tools, or you can let the auto router go to town. So the auto router will respect whatever's already previously laid out. So if you do want to use the auto router, the main strategy is route anything critical first, save the board, then let the auto router go to town on whatever's left. Okay, and that's what I'll do just to finish up the board. I'll click here on the auto router. It's a default setup, basically for 2-layer boards. I'll put low effort, hit continue. You'll see it's going to take everything into account. Whatever's already routed, it will leave alone. So I'll hit start. Now what it's doing, so that you guys understand, basically it creates multiple variations of the board. Okay, with different grid sizes. The first one uses a topological algorithm, so usually it's the nicest. It also tends to have the lowest number of vias, which is the case here. So, and as you can see, they're all a little bit different. They all, and what you can do is you just pick the one you prefer. For my taste, I prefer the first one. So I'll say in job. You'll see that it gets like this because that's where it routed through. If we do a rat's nest, it'll clean up. Okay. Now what can happen is depending on the routing, you can get islands, and that's what happened here. Okay. You have this island in the middle that's completely cut off from the main one, and
Also
these
known
error
as
bars here.
orphans, just to let you know, because the term orphan comes up often. So also known
Correct.
as orphans.
So you don't be surprised if sometimes after an auto routing run, you get this going backward. Basically, there's an island that has formed, and there's no way for Eagle to be able to connect it because of this island. And usually the easiest solution is just to route it manually. Go to bottom. Okay, right there. Oh, because I still have it on quick route. So what I can do is, didn't mean to have it in bottom.
Yeah, what it means is that the polygon is not able to pour that area and keep that part of the main polygon. Therefore, it will just, create that voided area.
Okay. And now if I rat's nest it again, everything is connected and happy. Or should be. Got that one. Oh, and I missed one more island over here. Dang it. That's okay. I'll just route to it, drop another via there, and there we are. Okay. And again, if I do the rat's nest, everything recalculates. You can see bottom, you can see top, and everything is happy. So that's it. That's the basics of the board. At this point, I'll save it. It's important when you're working with Eagle to always keep the schematic and the board editors open at the same time. That way changes in one can track to the other. If at any point you close one and continue working on the other, you're going to see a big yellow bar at the top say forward and backward as annotation has been broken. And then what's going to happen is the files become inconsistent. And in order to get them back to consistency, you have to correct them manually. So it's very important, avoid breaking consistency. It is one of the more painful of the errors and the issues that can come up with Eagle. So it's best to just avoid it in the first place. And the way you do that is keep your schematic and board always open together. Very key point. Okay, so that's the schematic, that's the board. Generating manufacturing data on a simple board like this is as easy as just clicking the Generate CAM Data button. It will actually analyze the board. It will give you a list of outputs that it wants to create. It will tell you that it will create them as a zip, and it basically is following this template. You say OK, and you'll see it asks you to save the file. Where is it going to be? It's going to be in Getting Started Demo. It's going to be a zip file. You hit Save, and then it opens the folder so you can see that there's your manufacturing data. You can unzip it. You can take it to a Gerber viewer. At this point, it's ready to be sent off. So that's the simplest case. And for most 2-layer boards and even 4-layer boards, that's good enough. If you have a more specific need, then you would get into the nitty-gritty of the CAM processor. But that's for another video.
Yeah, we'll be doing a manufacturing YouTube. We'll do a manufacturing webinar really soon. We're just waiting for some updates to come through, and then we'll schedule that one.
Okay. Any questions, Ed? Anything we need to address now?
John is asking us, that you were doing a little bit of manual work on the board when you were trying to get rid of the connections on the island.
Mm-hmm.
Now, he noticed that you used a via. There's two ways to use a via. You could actually use the via command. So he's asking you, how did you do the vias on the board?
Okay. So basically, you can place vias while you're routing, and that's what I did. So if I click on the route command, right now the active layer is bottom. So if I click, let's say over here, it'll switch to top. And then to place a via, I can either click with my scroll wheel, and you'll see that it places it. For a 1 or 2-layer board, that works pretty well. It's pretty easy, even for more layers. The other option is a spacebar.
That's the option I usually use. This is a spacebar.
I tend to like the spacebar myself also.
Yeah, I like to use the spacebar.
Okay. Once you left click to place the via, you'll notice that the routing continues on the other layer, and that becomes the active layer. You'll see it up here. Okay.
And if you have a 4 or 6 layer a setup for your board, just continue hitting the space bar. If you have like blind and buried vias assigned, you continue hitting the space bar to cycle through all the options that you have for vias.
Mm-hmm. And at the bottom, we can't see it now because the way my screen is scaled is kind of messed up. But at the bottom, you'll actually see some text telling you what layer it's going to go to.
Yeah, at the bottom status bar, when the via is actually placed, it will actually let you know what layer the trace, if you draw a trace from that point on, it lets you know what layer that's going to be on. Also, there was another question about the add command history, Jorge.
Mm-hmm.
There's not really a history, but I'll let you finish that one, Jorge, about that. Somebody's asking us about the add command history, if there is such a thing.
Yeah, it's this one. I showed it earlier. You see the little down arrow here? If you right click, it's basically a list of all the components you used recently. So that's the history. Everything you've placed in the design, the last 9 parts that have been placed will show up in this list.
Now, the components after they're placed on the schematic, no longer on the board, no longer depend on the library. But if everything is kept pretty organized, they will continue to back reference the library. So if you needed to like edit the component or access the component from the schematic to the library, you should be able to right click it and select the edit option. Now, if you've shared the schematic or the board with somebody else, let's say you emailed the board and the schematic, all of the information required for this board and schematic to work are there, but they won't really be able to back reference to the library because they don't have the original libraries.
Yeah, in those situations, what they'll do is they'll have to extract the libraries from the design itself, make whatever changes, and then update the design based on that.
And we'll go ahead and do that as a demonstration on another webinar as well. Okay, now also I'm getting, somebody's asking you, Ken is asking you, how did you remove the values on the silk screen, Jorge?
So if you want to remove the values on the silk screen, you just turn off T values and B values. T for top, B for bottom. By default, they are not included in the Gerber set. Okay, so you don't have to worry about them going into manufacturing data. By default, they are not included. But if you don't want to see them, you just turn off T values and B values.
Yeah, so we basically do everything by layers, so we enable or disable the layers accordingly. And the same thing can be done when you're generating your manufacturing data. I have a lot of questions, Jorge, so I'm just going to shoot off the questions, okay?
Yeah.
A lot of them are coming up. Robert is asking you, can you input schematics from other packages like OrCAD, etc.?
The schematic, the only thing we can import schematic-wise is PCAD ASCII. And even then, there's always some issues with it. Recently, we do have importers for the libraries. So if you do have OrCAD libraries or some Altium libraries, those can be imported using the library.io functionality. Those can now be converted to EAGLE libraries. But the design files like schematic and PCB, those, the best we can do right now is PCAD ASCII.
Which basically boils down to ASCII axle files. Yeah. Okay. I'm going to continue shooting questions at you because there are a lot of coming in. Is there an option to have EAGLE place the components on your behalf at the best possible location for auto routing?
Define best. That's the big problem. There's no universal definition of best. So over the years, there have been attempts at making auto placement UOPs, and there's several. Users made a whole bunch. But none of them ever universally caught on because everybody has a different definition of best.
Yeah, my best and Jorge's best are totally different, so I know exactly what he means. Okay.
Yeah, so no, to answer the question straight, no, there isn't any type of auto placement functionality. The ones we have seen in the past and in other tools in general don't work well, so we decided it wasn't worth the effort to invest into another auto placement tool.
Robert is asking you, can you just teach him really quick and review how did you toggle between board and schematic, please?
Sure. So basically toggling between board and schematic is up here. It's this toolbar. The fourth icon from the left in both is to switch. So if I left click now, schematic. I'm right back over it. Left click now, board.
Okay.
Okay.
Now, what happens when routing if you try to connect a net to the wrong pin? I'm a little confused here because he's talking about routing and then he's talking about net and pins. So I have a feeling he means mainly on the schematic side.
Okay. So Eagle doesn't know your design intent. So Eagle is just checking that the netlist is valid. So if the real circuit, for example here, the real circuit is supposed to connect from pin 2 to point 6. If you go from pin 2 to pin 7, Eagle has no idea that that doesn't work because it doesn't know the internals of the LM555 or what your design intent with it is. So you can't expect it to know that. You know, if the circuit is not electrically sound, from the viewpoint of electronics theory and design, Eagle won't know that. It doesn't have a brain to realize that, hey, you hooked this up wrong. What it can do is, for example, you can, let me turn on the layer 93 pins. You notice that the pins have different directions. So you have inputs, outputs. So what it can see is, for example, if you connect two outputs together, basically shorting two outputs, it will flag an ERC. It'll flag an ERC error. Hey, you're shorting out two outputs. So things like that, it can check. Those are very simple checks that it can do, but no, it can't infer your design intent.
So basically, if it is a wrong connection and you catch it visually, you basically just delete it and draw it again to the
Yeah.
appropriate place. Basically, is what needs to be.
Turned off the wrong layer. My bad. There. Okay. There's a question on the Q&A that I'm seeing. Did you do a multiple selection? Okay. In Eagle, there's three main ways to do multiple selection. They all involve the group command. So one way is just left click and drag. Okay. It'll form this selection rectangle. Okay. That's one way. It's the broadest. Another way is when you click on one element, you've started to define a group. You can then add to it using holding down control and left clicking. So right now I'm holding down control. I left click, I get that extra resistor. Left click, get this resistor. Left click, get this component. And that one is more fine grained. The last mechanism, which I think is the most unique because I've never seen it in other tools, is what's known as polygon selection. So what you do is you don't drag, you just left click and space somewhere. Okay, and you'll see that this line starts to form. And basically what you do is whatever you enclose with these lines, so say I wanted just this part here. Okay, when you reach the end, you just double click to close it. Whatever's in that shape, whatever shape you draw, that will be selected. So if you've seen I think the new Zillow commercials for Realtor.com or whatever, that you can draw out a search area, it's basically the same thing.
Okay, so let me just go through this really quick. How do you import LTSpice schematics into EAGLE Schematics?
So just to give some additional information on that, basically since we implemented the new LTSpice engine in EAGLE itself, work has completely stopped on the LTSpice integration. Our goal now is basically to be able to take an LTSpice schematic and convert it into something that LTSpice will run. That work hasn't been done yet, but that's the future. Right now, what you will do is you will you'll left click here, and you'll get this this menu. First thing you have to do is click Export Setup. That'll basically make sure that the UOP is aware of where your LTSpice installation is. It'll check that it has corresponding libraries, etc. If everything pans out, at the end it will tell you what those directories are. Then you can go import and so on and so forth. At this point, my gut feeling is that it probably won't work right off the bat. We've changed the file structures too much in how EAGLE is set up by default. But that is my gut feel. You could try it. There was an attempt to kind of port and kind of fix it up a bit more, but once the NGSpice integration came in, there wasn't seen the need to continue developing the LTSpice bridge.
Yeah, and it's getting better and better. The NGSpice engine that is being embedded into Eagle as well. Thank you, everybody, for joining us. We hope that the information I provided is actually able to work. And then one more question came up. We always try to keep these under 30 minutes, Jorge, but we always have a hard time with that.
Yeah, we're hosed.
Okay. Okay. Now, okay. So I don't see any other questions actually coming in. Let me see the Q&A. Okay. Now everything has been answered. Thank you, everybody. Have a great day. And if you have any questions, please contact us at support.eagle@autodesk.com or join us on our forums. Everyone, have a great day.
Bye, everybody.
Bye now.